Okay, so this second video is now going to look at us finding distances along lines of longitude, okay? And I am going to go through this in a slightly different order to what your textbook goes through things. So I recommend like these little black bold headings. You do the questions in the order of these little bold headings because to me this way makes a little bit more sense, okay? So the first point is for us to find the distance from a point to the equator or to the poles, and this is us working along the line of longitude that the place is on. So this first one says New York is located at 41 degrees north and 74 degrees west. So to start with here, sorry, let me go back to my 3D map that I like. No, it's this one here. If we were to find New York, we'd go this way, make our way to America, and hopefully you agree with me that New York is chilling like somewhere up in here. And so it's at 74 degrees west there as its line of longitude. So what we're saying is, let's pretend it's just this exact blue line. We're taking this blue line here, we're cutting the earth in half along that blue line. And what I'm going to do is I'm going to imagine that I'm pulling this face away, and I'm just going to draw a circle to represent this line of longitude through here. So if I come back here for a second, I'm just going to pause the video and put a circle in for us. I want you to think of this circle as representing my 74 degrees longitude line that I've cut the earth on that line. And if we look at this circle then as well, what we can do is I can put in a horizontal line here to be my equator. So remember that has a latitude of 0 degrees. And I could put in this vertical line here, which has got my north up here and my south down here. And we can talk about the center of the earth in here as being point O. Now, if I'm talking about New York, it's located at 41 degrees north, so I could draw New York being along this circle. So let's put New York here, okay, with a line like that, and we then know that it is at a latitude of 41 degrees north, which means this angle in here for me is 41 degrees, okay? Now, the rest of this question asks us to determine the distance from New York to the equator, to the North Pole, and to the South Pole, and give all of our answers to the nearest kilometre. So if I'm first of all trying to find the distance from New York to the equator, it's wanting me to work out how long this section here is, which means to work to the equator, sorry, that's the crap part of my screen, so let me just write that again. To work to the equator, I just need to focus in on this little wedge here, okay, where I know this is my equator, this is New York, this is 41 degrees, this was the center of the earth, and both of these lines of this wedge are actually equal to 6,400 kilometers, because remember they are my radii of the earth there, so 6,400 kilometers. Now, for me to work out this curve distance here, I need to go back to that formula for S that we were using in 19A, which is S equals pi radius theta over 180. And if I now substitute in what I know, I'm saying pi times 6,400 times 41 degrees all over 180. And I can put that in my calculator, exactly how it's written. So let me set up a fraction. I'll put in pi times 6,400 times 41 all over 180. And to the nearest kilometre, we will say that that is 4,580 kilometres. So it's 4,580 kilometres from New York to the equator. Now, the rest of the question asks me to then find this to the North Pole and to the South Pole. If we're wanting to find the distance from New York to the North Pole, that's actually wanting us to now find this green part here. And so for the North Pole, we now want to work with this top wedge. I've got N for North Pole, O for the center, New York, okay? And this theta here, we don't know. Now, remember that fully north is 90 degrees. So this angle theta is actually going to be equal to 90 minus 41, because if I had this in, we know that this little bit down here is 41 degrees, okay? And so theta is going to be equal to 49 degrees. So when I'm now trying to find this distance, I'm going to still go back to this formula, pi times 6,400 times my angle. This time I'm putting in 49 for my angle, and I divide all of that by 180. And you can be a little cheeky in your calculator, and rather than retyping that each time, you could just change the angle on the end. And so to the nearest kilometre, this time it's 5473. So we are saying that New York is 5,473 kilometres from the North Pole. Lastly, if I work this out for the South Pole, then the South Pole is me wanting me to find from New York all the way around to that South Pole. Sorry, I'm not sure why that's highlighted funny, down to the South Pole, which means I'm actually now working with a much bigger wedge. So this is O. Remember, my radii is still these two distances, so these two are still 6,400 long. South Pole, New York. And I've got 41 degrees here, and this here is 90. So the angle that I'm going to work with this time is 90 plus that 41 degrees. So theta is going to be equal to 131 degrees. And so now if I take my formula, I'm doing pi times 6,400 for the radius of the Earth times 131 degrees, all divided by 180. And if I pop that in my calculator, again, I'm just going to change that angle on the end now to be 131. And I get 146, and we'll say 33 on the end to the nearest kilometre, so 14,633 kilometres from New York to the South Pole. If we scroll on down here, the next section then gets us to find the distances between 2 points with the same longitude. So if they have the same longitude, it means they'll be on the same great circle or on the same meridian, okay? Longitudes can also be called meridians. So what we've got here in question 1 is that New York is located at 41 degrees north and 74 degrees west, and then Bogota in Colombia is at 5 degrees north and 74 degrees west. So they both have this longitude of 74 degrees west, and it wants us to determine the distance between the two cities around a great circle, which means around that 74 degrees west line of longitude. So let me just put a circle in for us again here, okay? This circle is going to represent for us that 74 degrees west line of longitude. So once again, if I look back at my globe, we're saying New York's up here and Bogota in Colombia is down here. So we've taken this line of longitude and cut it in half, and I can draw both of them on the map, okay? So again, let me put in the equator for us, which is at 0 degrees. Oh, that's a pretty unstraight line. Let me put in north and south for us, okay? And this is O being the center of the Earth. Now, we can have New York up here, and I'm just going to put in bracket 41 degrees north. We knew that from before. Bogota is located at 5 degrees north, so Bogota is just going to actually be slightly above the equator at 5 degrees north, and we'll draw that in there. And both of these black lines represent our radius of the Earth, so they're both 6,400 long, and we're trying to work out what this red distance here is. So to focus in, we're just focusing in this time on this wedge that has New York and Bogota, 6,400 kilometres. And now we need to know what theta is here. Now, because they're both north, they actually have that overlap of 5 degrees. So for us to find that angle, I can do 41 degrees for New York minus the 5, which is equal to 36 degrees. And now I can take that formula for S again, so pi times 6,400 times 36 this time, all over 180. And again, if I go to my calculator, I can just change this number on the end. So I'll just change this to be 36. And to the nearest kilometre, that's 4,021 kilometres between New York and Bogota. If I slide on down here, we've got now another city, a third city. It's at 35 degrees south and it's on 74 degrees west. So it's actually still on this same line of longitude that we have been working with, okay? So let's put this circle in again, and it's still representing that 74 degrees west line of longitude. And it wants me to find the distance between New York and this third city. So let's put my equator in for 0. Let's put in my north and south. And still we know that this up here is New York at 41 degrees north. Now this new city is at 35 degrees south, which actually means I'm now going to work from the equator 35 degrees this way. And so down here, I'm just going to write 3 for that third city, 35 degrees south. And both of these black lines are still that 6,400 length because they're going from the center of the Earth out to the outside of the sphere. So to focus in, this time we're working on this wedge here, where we've got New York, the third city, the center of the Earth. The radii are both worth 6,400, and I've got to know this angle here. And what we can think about with that angle is the equator splits it, and it actually comes from adding the 41 degrees north for New York plus the 35 degrees south for my third city, and that adds to be 76 degrees there in that angle. So now if I find this side length, I'm doing pi times 6,400 times 76 for that angle, all over 180. And if I pop this in my calculator, I'll just change that final angle to be 76, and we get 8489 kilometers to the nearest kilometer there. All right. That is us working with lines of longitude, and I'm going to stop the video here and record a third one to find distances along the lines of latitude.